One.
Hi, everybody. This is applying the coherence map across the K-12 mathematics curriculum. My name is Diana Sapala. I teach at Northern Valley Regional High School in Demorest, and my co-host is...
I'm Dina O'Brien. I am a K-5 math specialist in Edison, New Jersey at James Madison Primary and Intermediate School. So part of my day is working with RTI students and part of the day is coaching teachers. 2 years ago, I became a New Jersey core advocate and was introduced to the Coherence map as a tool. And I use it personally to address the gaps of my RTI students. But I also share the tool with teachers during coaching visits. And if a teacher has a concern, based off of a pre-assessment or a lesson or even a post-assessment that a student hasn't mastered the skills, we use it to map the standard and see where the gaps truly lie. So I'm so excited to share this tool with you and how to use it in your classroom. So let's go on to the next slide.
So we thought this was appropriate. Joe Bowler is one of the, big advocates of mindfulness. Math is a subject of beautiful connections. It's not a long list of disconnected topics. So we thought it was appropriate for our presentation tonight.
Okay, and just to kind of give you an overview of what this webinar will be, the introductions, which we've done already, we're going to give you a, quick overview of the coherence map and guide you through a strand. So we're going to look at a middle school strand and see how elementary strands contribute to that and what middle school is preparing students for in high school. Then we're also going to kind of talk about the coherence map as a differentiation tool and kind of how you can use that to challenge your students, to create stations where the teacher just acts as a facilitator for the students, whether they're entering your room below grade level and need tasks and lessons to fill gaps. And also kind of form that deeper understanding of skills for students who are showing evidence of mastery. And then we'll have some time for questions at the end. But if you do have questions, feel free to place them, in the chat area as we go through on a particular slide.
Okay, this is Jason Zimba's chart. He's basically trying to show you that, no matter where you are in your elementary topics, when you're going through all the elementary topics, and the big ideas, operations in algebraic thinking, number and operations in base 10, number and operations fractions, expressions and equations, number systems. It's all going to feed into algebra. It's going to build all the concepts for algebra so that when students go to high school, they will have all the tools necessary to be able to do all of the math that they need in high school, all the algebra and all the upper level mathematics courses in high school.
So this is probably like one of my favorite documents to kind of look at. And this is the focus area across the grade levels. And it's so important to remember that as teachers, that we need to stay in our lane within the grade level. An important subset of the major work in grades K through 8 is the progression that leads towards middle school algebra. So like thinking across the standards that are designed around coherent progressions from grade to grade, like we need to connect that learning across the grades so that students can build that new understanding like onto foundations that were built in previous years. So when we think about standards, we need to think of them not as each one being a new event, but as an extension of previous learning. And this is so important, I feel, when differentiating in your room, that like differentiated instruction is not just pulling like a small group to the back table and teaching them the current lesson that you're doing at a slower pace, or just breaking it down for them like in mini steps. like you may be required to kind of go back to a previous grade level standard, or maybe even back 2 grade levels to kind of address those gaps.
And I think actually, if you do math stations in your classroom, that's a great way to address differentiating instruction and deal with that kind of situation. All right, moving on. You want to go over the vocabulary? I forget who's supposed to do this.
You are, Diana, but I mean,
I could do it.
Okay.
Okay. Coherence. It's linking the major content between each of the grade levels. Major cluster. Now, you probably remember a lot of these terms came out with Common Core and the Park, just to remind you where these terms come from. Major cluster, it's the standard that the major part of the work for the particular grade is, as a reminder, 65 to 85% of the instructional time over the course of the year should be focused on major work of the grade. So this major cluster. Then you have supporting. This represents rethinking, linking areas where some material is being covered, but in a way that applies core understanding. And that's about 20% of the year and of the instructional material. Additional, expose students to other subjects, though at a district level, at a distinct level of depth and intensity, and that's only about 10%. So, in other words, you're just that's additional, kind of additional subjects that also really, in a way, support that major cluster in a way. Did you want to add anything?
Nope, that covers it, because I think I actually touch upon this later on too, as well, in one of my slides.
You do.
Okay. Okay, so these next couple of slides are just kind of like screenshots of how to access the Coherence map. And we did want to kind of put that link in the chat box, but it is achievethecore.org/coherence-map. And once you go to that site, you will get a screen like the one shown here, and you're just going to click on the words "Get Started." Once you do that, you will choose your grade level, and there's all the grade levels from K to 8 are listed. So you would just choose your grade level, and then on the next screen, you would choose the domain. So whether it's counting and cardinality, operations and algebraic thinking, numbers and operations in base 10, numbers and operations in fractions, measurement and data, or geometry. So I actually love that, like, a lot of our assessments that we do, they definitely have that New Jersey Student Learning Standard, or for those people that are, still using Common Core. So it's very simple on the Coherence map to kind of match that standard just by going through these steps, and choosing the grade level and the domain. And then on the next slide, you find and click on the identified standard to map it. And then you would click on the words at the bottom that say map standard. When you click on that, you'll see that it's color-coded by a green square for major cluster, blue square for supporting cluster, and a yellow circle for an additional cluster. So it is important for teachers to know what cluster it is and how much time should be spent on a skill. And we addressed this in the beginning of the webinar a couple slides ago, but just to recap, like 85% of your instructional time over the course of the year should be focused on that major work. And then approximately 20% on supporting and 10% on additional. It's so, like, everybody has that student that just isn't getting that skill. And you know what? Like, it may come back to kind of mapping it backwards and, really honing in on a different skill that then they could later apply to the current skill. And then, when they get into the higher grades, they may come back to this standard again in a higher grade, but now understand it a little bit more to be able to move forward. And then what you'll see is once you map that standard, you'll see the cards on the left identify prior knowledge standards. And to identify prior unfinished learning, you would click on these cards. You'll choose the standard that you think matches the student's needs. And what I like is that if you keep clicking and kind of lose track of where you started, you will see in the top, I think it's the top right corner, you'll see kind of like one of those map symbols, like to show you were here. So I like that because that kind of brings you back to that original standard that you started mapping. And then within each of those standards, there's tasks, there's progression documents, which are very informative to read, and assessments to use that support the students. These assessments were very eye-opening to me when I gave them to my students, because it hones in on the standard for conceptual understanding, fluency, and rigor needed to master the standard. It's kind of like all of those combined. A lot of times students kind of have one of those, but not everything. And when you ask them to apply it, that's kind of where their struggle is. So I like the assessment tasks and the tasks that are in there.
Just a little note about the progression documents. They are, a lot of them also give you a little more insight on how to teach some of the topics and ideas. It also kind of gives you a little insight on how some of the Common Core standards were developed. But those progression documents are really informative. So if you have an opportunity to look at them, I would, take some time to do that. And like Dina said, you can sometimes get lost in the coherence map. So it can easily guide you right back to where you were. So this next one is, we thought we would start off with one of the grade 6 ratio and proportion. So it's 6 RPA1. Understand the concept of ratio and use ratio language to describe a ratio relationship between two quantities. For example, the ratio of wings to beaks in the birdhouse at a zoo was 2 to 1. For every 2 wings, there was a beak. For every vote candidate A received, candidate C received nearly 3 votes. So now, how does this relate to the elementary standards and the middle school standards?
And I just think it's very important to kind of, just for teachers and educators to understand that we are all connected. There's no more of this, oh, I teach elementary school, I don't need to know what goes on in middle school. And there's none of that middle school, like, oh, I don't need to know what goes on in high school. Like with this coherence map, you really see the connection between all levels of education. So if you look at this standard that we chose, the 6RPA1, you can really see how, and this screenshot just has a few of the previous grade level standards that are needed. So you figure, wow, a 6th grade standard, and I might have to go back to 4th grade to kind of address the gaps that they have. And the most eye-opening thing for me was when I looked at these 3 standards, and if you look closely, you'll see that blue square in the top one for 4MDA1. So yes, in 4th grade, that is a supporting standard. But when they get to 6th grade, you're in a major cluster for 6RPA1. So, it's just kind of like to see that connection and how we do have to still focus on those supporting clusters because they are going to be needed in future grades. But, like as a 4th grade teacher, you might think, oh, I don't need to really spend that much time on that, but you do.
If I also want to point out, do you see how you have the arrows? So it comes out of one standard and then it goes into another. So a couple of things I want to comment on that. One is that if it goes from one standard to the other, the next standard, and they haven't mastered the one it came from, it's possible that they may have trouble with that next standard. But it doesn't mean that they have to absolutely master that previous standard, but they should have some understanding of it to be able to do the next standard. And that's just sort of to give you an idea of, you know, how they're connected. I don't think we had mentioned that before, did we?
No, that was a good point. So on the next slide, you'll see each one of these three kind of standards that were in my screenshot. Within the coherence map, you can find tasks based on that standard. So that's great for, you know, small group instruction. So here's like a 6th grade teacher trying to teach this standard, realizes that they have to go back to a 4th grade skill and might be thinking and kind of be panicked that I don't have 4th grade material. So that's the great thing about the coherence map, is that they give you these tasks and these quick formative assessments. So you could see here in this 4OA2, which is the major standard in 4th grade, using the 4 operations with whole numbers to solve problems. But what you'll notice in this task is how they use tape diagrams. Some people call them bar models, thinking blocks, but it can lead to them understanding ratio and proportions to see it as parts of. And I think about that now as I work with students in the primary grades, modeling problems and kind of giving them or having them represent problems in different ways, whether it's a number bond or a bar model, you know, or a tape diagram. Like, I feel like, wow, I'm actually preparing them for 6th grade. You know, I'm thinking way ahead for them. And knowing this will help them in the future, you know, and it kind of makes the struggle like, okay, this is fine. The next slide also has, again, this is a prerequisite task that leads up to 6 RP. And you could see this task gives students practice in relating units within the metric system and expressing larger measurements in smaller units within the metric system. And it's an opportunity to reinforce the notions of place value. So students also, you know, combine competencies from different domains as they solve measurement problems using all 4 arithmetic operations: addition, subtraction, multiplication, and division. And again, all of these tasks, you know, can be found right within the coherence map if you scroll all the way down to the bottom and click on the word tasks.
You want me to do it?
I'm sorry?
Would you want me to just go out of this slide and go into and show that?
Sure.
All right, I'm just going to abandon this, harden my desktop for a second, and I'm going to quickly go into that. So I happen to pull it up already. Yeah, I have a lot of tabs all of a sudden open. I don't know why. All of a sudden, a bunch more opened, and I didn't.
Yeah, and a lot of their tasks do come from illustrative math. You know, for those people that are familiar, you know, with those tasks, a lot of them are linked right into the coherence map.
So what I wanted to show you is that you can see here, we have 6 RPA1, and then it's got a task here. You can even click on more tasks, bag of marbles, which I believe, yeah, it is illustrative math. So, and you find it. You'll see that a lot of them are from, as Dina said, illustrative math. There's also some that are from other places as well. Oh, Smarter Balance. I was going to say Smarter Balance, but there's even a tab for that. That's right, I forgot. And the assessments that she was actually talking about, here are the mini assessments, just to kind of quickly show you. You can download them. So just to show you, they have it very nicely laid out. I think they're very nicely laid out. In fact, I did a workshop last week. I showed this last week in my workshop. So I think it's very easy to get to, and you can get a whole bunch of different tasks.
Yeah, and I know teachers that I've kind of shared this with have actually like sometimes used it as a whole assessment, but then other times cut up the problems and used it as a quick formative assessment or like an exit ticket at the end of the day. So that, or at the end of the lesson, the math class, like they would just cut one of the problems and see, okay, like, you know, who do I have to work with tomorrow? So there's so many opportunities within the assessments, you know, on how they can be used.
We actually last week used them. We just took a problem or two out and used them for our math stations. So
that's another great idea.
Yeah, found it kind of easy to do that. So I just thought we'd take a quick look at this stuff, and then we'll go back to our slides, just so you can see. So as you can see, there's smarter balance. And then, sorry. So this is where to focus. This is what we were talking about, the major, the supporting, the additional clusters. So, and that's for each of the grade levels. And this is where the one slide you saw earlier. All right, I'm going to go back out of this unless somebody wants to see more from this. Okay, and I'll go back into our slideshow presentation.
Yep, I think we're on slide 16 now.
Here we are, sharing chocolate.
Yep, I know, right? As I was looking at it, I was like, this is perfect. So like, again, one of the, you know, prerequisite standards is actually a fraction standard in 5th grade. And what better way to kind of talk about it with children with chocolate? So in 5th grade, they actually start to connect fractions with division and understanding that 5 divided by 3 is the same as 5 over 3 written as a fraction. And students have, since grade 1, been using language such as, you know, third, half, quarter to describe, you know, one part when it's partitioned into, you know, blank number of parts. And with their new understanding of the connection between fractions and division, students now see that 5 divided by 3 is 1/3 of 5, which leads to the meaning of multiplication by a unit fraction. And then this leads to their understanding of proportions.
I think we were just showing this to show that the connections going on to, now we're going to actually go to the right of our 6RPA1. So as you can see, 6RPA2 was the next one at the top. And so they were learning all about the fractions, and now they are learning about unit rate and ratio. So as you can see, 6RP2A2 understand concept of unit rate associated with a ratio A to B with B, 0, and use rate language in the context of ratio relationship. So for example, the recipe calls for a ratio of 3 cups of flour to 4 cups of sugar. So there's 3/4 of a cup for each of the sugar. 3/4 of a cup of flour for each cup of sugar, which is that kind of what what Dina was actually sort of talking about earlier with the fractions. We paid $75 for 15 hamburgers, which is a rate of $5 per hamburger. I actually retyped it down there. I see that. And then, of course, So that leads then on into seventh grade, a seventh grade standard. And that's seventh grade standard is 7 RPA1. Now the students are gonna compute the unit rates associated with the ratio of fractions, which include ratios of lengths, areas, and other quantities measured in like or different units. For example, if a person walks a half a mile in a quarter of an hour, compute the unit rate as a complex fraction. So it will be 1/2 over 1/4 miles per hour, or equivalently 2 miles per hour. And that's when they simplify that, of course, that's what they get. And then that leads into, and clearly, as we said earlier, you don't even need to do that directly next, but knowing this is going to help build understanding for 7 RPA2. The next slide.
And I mean, I'm just hoping, like, as people are kind of looking at this progression, really, that we're showing them almost from, you know, like I mentioned, first grade all the way to seventh grade. Like, it's so important, like, you know, talking about fractions, that they understand, and you could see this progression of understanding happening. It's not just, you know, inverse operation, you know, flip and multiply. Like, it's so much more than that throughout these standards to figure out ratio and proportion.
Absolutely. So students basically, as you can see, the students' knowledge of 7 RPA-A2, that helps them with, you know, 7GA1. Notice that's also one of the different major clusters, G meaning geometry, whereas RP is the ratio and proportion major cluster. And then, of course, if you even look down in 8th grade, it's the expression and equations that it, you know, helps students understand. So right now, what we did was we just chose, you know, one of them, just so you can kind of get an idea of going through them. So 7 RPA2, recognize and represent proportional relationship between quantities. So of course they're going to decide, one of the things they'll decide whether two quantities are in a proportional relationship, and they'll test for it. They'll identify the constant proportionality, the unit rate, which we've talked about that. For those of you that teach upper level math and algebra, you could probably see how that's going to nicely go right into algebra and set students up for their understanding of, you know, the concept of slope and going into linear relationships and linear functions. So it's really important for them to understand each of these standards. And even, you know, I teach Algebra 1. So there are times where I know I have to go back and I have to actually, with certain students or maybe a group of them, and go over certain concepts that are in, say, 7th grade. And it's usually the 7th grade area, because there's just so much in that grade, I find, that students need to understand that they lack that understanding.
Yep. And no longer are we just experts in our own grade level.
Right.
You know, we're expected, you know, to really fill those gaps and, you know, become experts in the progression and not just our given grade level that we're teaching.
Yeah, it's funny that you say that. I think that notion is probably, or was probably, more true with elementary, where I'm a 5th grade teacher, or I'm a, you know, whatever grade teacher, and didn't know. Where in high school, where I could be given this year Algebra 1, and then, you know, I could be given calculus next year, or so we kind of always really sort of knew needed to know that progression. But there's no more. Here's what I think with the high school teachers is, we cannot sit there and point figures at, and I know a lot of teachers do this, at the middle school, well, they didn't teach it there. Well, they probably did. There's a lot of things that could happen. Students could be absent, for a number of days. It could
Mhm.
be that, it just, or a teacher goes out on maternity leave. There could have been, maybe a different sub, every day or whatever. You never know what the situation is. So I
And
think
what
it's
another
all of our
uh,
responsibilities. It's not just one person's responsibility or the teachers. We're all together. We're all one. So we're all have access to this progression map, and we can go back and we can check that out. We could say, oh, okay, so it looks like, maybe I have a whole group. Maybe one of my 3 Algebra 1 classes need help with this, and I have to go back, with that group,
right.
and teach them, some stuff, some concepts that they may not have picked up, in 7th grade or in 8th grade or even in 6th grade. Who knows? And the
Mhm.
coherence map, I think, helps, to look at those things and to
Yes.
see what's really going on.
Yep. And
And
I think it's also important that we don't always just wait and say, oh, they'll get it next year. They'll get it next year. Because if every grade says that, if every, grade level teacher says that, oh, this is just a supporting, standard, they'll get it next year, or that gap is getting bigger and bigger for the students. And that's kind of what's happened. That may be why, there is a larger gap of students that are struggling, because I think now people's mindsets are changing and saying, no, this is my responsibility, and I could address their needs using the coherence map.
exactly. And I think there's a lot more tools for us to, as teachers, to use to help differentiate instruction. We did talk a lot about the math stations, and I think that's one way you can do that, and one of the best ways, in my opinion. I don't know, Dina, do you recommend other ways at the elementary level?
No, I know there are definitely a lot of, math stations and math centers going on. And, teachers are using that time to actually pull small groups and address these gaps at that time.
Yeah. All right. So now, as you can see, so we went from 7 RPA 1 to 7 RPA 2. And now, of course, that 7 RPA 2 supports many other standards, not just the ones that are there. That just screenshot just got that part of it, just to let you know.
Yes.
I want to make that clear.
Yeah.
And then, so now in 8th grade, oh, actually, sorry, I forgot we had some examples here. So which of the following statements about robot B are true? And of course, our students absolutely love the select all that apply, as Dina's chuckling.
Yes,
At least,
because my son's in middle school, and I always tell him that when you see something that says select all that apply, that probably means there's more than one right answer.
exactly.
So it's just, to really think about how many possibilities could be true.
Although I do have to say, honestly, I actually had written problems for Park. They said that we could write, where there's only one answer, but to be honest with you, the general consensus amongst all the writers were, if we're going to put that, at least have 2.
Right. Yeah.
So, as you can see, this really very nicely. So this goes into one of the reasons why I selected this particular problem was I love the fact that it not only did it address that 7th grade standard, but it just also just goes nicely into the whole graphing of linear functions, and the understanding of the graph, time in seconds and what a rate really is. And of course, that really is the underpinnings for slope. So we went from 7 RPA 2 to 8 EEB 5. Oh, we went into expressions and equations. So as you can see, even the major topics also integrate with one another very nicely and support one another. So in this one, they're going to graph proportional relationships, interpreting the unit rates as a slope of of the graph. Boy, I guess we've heard that before about slope. Sort of brought that up just in the previous slide. And we compared two proportional relationships represented in different ways. For example, we might want to compare distance time graphs, distant time equations to determine of two moving objects has the greater speed. Okay, so they would have to take a look at the graphs or even the equations and kind of understand what's going on there. So as you could see, it's really important for children to understand the fractions and the whole progression of the fractions and comparing fractions and dividing fractions and then turning it into unit rates and moving it on to understanding it in terms of slope. So it really is very important that students understand all of the major clusters and all of the supporting material. So now if we take a look, so it's funny how that 7th grade and the 8th grade looked very similar, which is another reason why I chose this. But if you take a look, they really truly are two totally different problems, because now what are we asking for in this particular case? The graphs below show the distance two cars have traveled along the freeway over a period of several seconds. Car A is traveling 30 meters per second. Which equation from those shown is the best choice for describing the distance traveled by car B after X seconds? And they have to explain that. This is, again, deciding which one has, the greater rate and understanding what's going on in the graph and how the equation relates to the graph. So it took that 7th grade problem a step further. So that's pretty much the reason I wanted to show those two examples, because I thought that was a really nice parallel going from 7th to 8th grade.
Okay, so we're up to our questions. If anybody had any questions, maybe we're putting them in the chat area, because there's nothing wrong with being unsure. Clever people ask the most questions.
Very true. No, I can't see the chat area. So this is on you, Dina.
And let me, I don't know if Steve and Josh, I thought, were monitoring the chat area.
All right, let me get out of it. Let's see. I think I could figure something out here.
No, there are no questions so far. So I guess that means that we did a great job explaining. Right? I think we could give ourselves a pat on the back for that one. But going on, Diane, if you want to go back to the next slide after the questions,
yeah.
Because we do include our contact information.
Right.
And hold on, I think I typed my email wrong, so I'm just fixing that. So we have our emails there, and just to kind of reflect on the coherence map, and I kind of found that picture because I thought it fit perfectly, that we are here to guide you. We'll hold your hand through it. Just to think about when you are using the coherence map, think about whether this standard is a major, supporting, or additional standard, whether it's on your grade level, a future grade level, or a prerequisite standard, so focusing on how they're connected, what standards are connected to the current standard, which progressions document includes this standard. And like Diana and I both said, that really is a good read. Like if you really want to focus on that standard and how to teach it at your grade level, they give great examples. And how can I use this to address gaps or mastery of my students? For students who've already mastered something, maybe you want to have them try to apply it to really see, do they just know the procedure? Do they really get that conceptual understanding?
That's really funny. When I saw that picture, I was thinking we're walking hand in hand, and all of us, all teachers are just walking hand in hand, moving everybody forward, you know. Just I thought that was kind of cool.
Yeah.
That
I searched long and hard for that. I
yeah,
had a picture in my mind and I'm like, I need to find it. So
yeah, it's a nice picture.
So I guess that's it. Like I said, if anybody needs to reach out with any questions, please feel free to use the emails, at the bottom of slide 25. And Diana and I will be happy to, answer any additional questions for you.
All right. Nobody has any questions, huh? All right. Well, I hope everyone has a wonderful evening. It's been a pleasure. And by all means, please feel free to send us an email. And like we said, please use the progression documents. I use it when I least expect I'm going to use it. Like last week when I was doing my workshop on math stations, I didn't expect to be pulling up whipping out the coherence map, but I ended up doing that with the group. So it was pretty neat. All right.
All right.
Have a great evening, everyone.
Thanks. Bye.
Bye.